It was done by Lingshan Su and a whole team of other people that most of them from the Peak of Excellence Center on Health and Food Technology at the National University of Singapore at Chuzhou. That's a research institute. What they've done is they've made an edible plant-based kind of scaffolding material that can be used for 3D printed protein and 3D printed meat. The idea is that they have an hydrodynamic 3D printing process, kind of a jetting process essentially, for 3D printing. And they put horidine or seculin in that. Those are seed prolamins or storage proteins from plants. And they're specific. The horidine is from barley and the seculin is from rye husks. And they've taken this material, which is usually it's a waste material. It's kind of the husks that are discarded in the processing of food. You don't eat it; it's just surplus. So anytime people use like agricultural waste materials that are discarded, like corn husks, stuff like that, barley seeds, all that kind of stuff, it's absolutely fantastic, of course, because we're putting energy, we're putting water into that protein or that vegetable or that mineral, whatever it is, and now we're going to be able to use something extra. So because of this, the scaffolding material is actually quite cheap, which is wonderful. And yeah, it's environmentally super friendly, of course, because there's no extra cost associated with making it. Now, this also leads to an edible scaffolding material that you can add and then grow the structure of the meat or the cultured meat on. And the idea is that it would then make that process cheaper. Now, of course, if we're looking at cultured meat in its entirety, then the whole entire process of growing the stuff on and culturing it, growing it on culture, and in the culture medium, and all that kind of stuff, all the energy that goes into it, it's much more considerable than just a scaffolding material. So this isn't going to really, well, it's going to push the needle, but not a lot in the grand scheme of things. But it's wonderful to see people work on stuff that's a process improvement to this 3D printed cultured meat revolution, which may or may not be upon us. I'm still not sure if this is going to happen or not, because part of it depends on the marketing. I mean, lab grown meat, if it's continuing to be called lab grown meat by everyone, is not going to go anywhere. I'll tell you that much. On the other hand, if we start using cultured meat and they market it well, maybe this could be a very big industry indeed. So we'll wait and see. The next news is from AM Novus. AM Novus is a Belgian company that is made up of a bunch of really experienced people, some of them ex-Layerwise, which of course is a Belgian 3D printing service, and later OEM for powder bed fusion equipment. Now they right now in the AM Novus incarnation have started 3D printing medical devices and started helping companies commercialize these devices. So a lot of people have like an orthopedic implant kind of idea or invention and looking for somebody else to help them take this to market. Now they're doing something which, well, at first blush, first glance, doesn't maybe look to be in their wheelhouse, but what they're trying to do is they license the technology from the KU Leuven, or the Catholic University of Leuven, which is a very storied university in 3D printing research due to their proximity to Materialize in part, but also, they've got some really excellent university researchers there that are just a little bit ahead of the curve when compared to everyone else. Anyway, so the KU Leuven invention was for a novel copper powder bed fusion production kind of, I guess, technology or production process in the broadest sense. Now, this is copper, chromium, zirconium material. It's a relatively widely 3D printed material. And right now, well, it's really difficult to print it. Everybody's been trying to do this for a long time. You need really expensive green lasers. You need some pretty tricky settings, and then it doesn't really work very well. Now, what the university has done is developed a proprietary laser absorbent powder, right? So they kind of mitigate the high laser effectivity of the powder, and also the really fast energy deposition, which is some of the things that make copper so difficult to print, and at the same time make it such a cool material that people want to print. At the same time, they say these powders have better flowability, really good oxidation resistance. There's less powder aging generally because of this, and there's some better reusability and shelf life, which is, of course, always a nice characteristic. Of course, it's going to be much cheaper to process because you don't need a really, really expensive laser and really, really expensive new machine. They say that the density is above 99%, and they have really good electrical heat conductivity on the final parts. So, that's very, very encouraging, I think. And Nova seems to be like branching out at least into licensing this technology and commercializing it. And they seem to be branching out from just doing medical to much more industrial applications. We all know that copper is a much desired material in part because things like heat sinks, electric drives, electronics, electrical components generally, and this could be a hugely popular material, right? The large stuff is being used for combustion chambers and rocket parts, but there's plenty of small, tiny parts looking to be 3D printed as well, and copper 3D printing could eclipse the entire rest of the metal 3D printing industry if we just, found the right commercial applications for it. And these could be much quicker to implement than medical, which of course takes a long time. So I think this is, yeah, some quite surprising. I thought AM Novus would really, really stick to medical stuff, but quite surprising, quite good news, I think. The next news is, also a kind of a rare material, even rarer material for 3D printing, and this is the gold. So the Bentley Batura, which is a completely over-the-top car, now has a charisma dial, and that charisma dial, by the way, if you're wondering, a charisma dial, if you can dial up the charisma of the driver or the passenger or something like that. No, that's actually a dial on the in the center console that lets you select the drive mode of the car. It's like a BMW iDrive kind of thing. It's called the Charisma drive dial, and that is now being made in part with powder bed fusion for gold. Right. Now, what I love about this is that the company talks that the gold that is being used is being recycled from 18 karat gold jewelry. So Bentley took it upon itself to really kind of include in this press release and around this to include the where the gold's coming from. And I think there's a lot of opportunities for there in a more ethical gold, and there's also a lot more opportunities in like a more less CO2 kind of metals as well. And I really piqued my interest to see that happening. Now, this is going to, even for Bentley, it's not going to be a lot of volume. We know that a lot of the Bentley Mulliner people have been using 3D printing and 3D printing of precious metals for their kind of crazy off the top, you walk in, you get whatever you want kind of customization. And now it's, kind of like trickling down to the mere mortals that can afford the more standardized Bentleys. So, from the whole scheme of things, this is probably not going to be in your local your car, to be honest, anytime soon. Now we don't know a lot about who's doing it. It's powder bed fusion. Given the volumes, I would think it would be outsourced, to be honest. Um, and at the same time, like the logical partner would be then Cookson. Cookson's a large player in this kind of gold processing, gold service and all this, and then likely to have already had a relationship with Bentley in the UK. They both have strong presence there. Um, and Cookson also commercialized the AOS M80 for precious metals as well. So it's the most mature platform. There's a couple other little options. One tantalizing one would be to use an old concept laser machine to do this. But generally, I would assume that they outsource this at the moment. This is still going to be only for them, small volume. I assume it's M80 and Cookson. But hey, generally, this is another kind of like commercialization of in the high end side of things in the car space, and kind of positive news in this sense could really drive adoption in broader and larger automotive. My name is Ross Peels. This is another edition of 3D Printing News Unpeeled, and yeah, I hope you have a great day.